Hi guys, and welcome to the second last lesson from our quadratics chapter. Today we're going to be talking about the discriminant, where it's come from, and how it is beneficial to us in solving quadratic equations. So here is the quadratic formula, and we've discussed this at previous lessons, how to use it, and obviously why it helps us solve our quadratic equations. Now, if you look at this particular equation, it's consisted of a few parts, but we are only concerned with a small fraction of it. The discriminant is actually this part of the quadratic equation, the b squared minus 4ac. Now, the reason why this is important is because it tells us a few things about our quadratic equation. For example, if the value, when you put this into your equation, b squared minus 4ac, is less than 0, i.e. a negative number, there is actually no solutions to the question. That means that it is unable to be factorized. You cannot use the equation to solve it. There are no values of x that make sense to us in terms of rational numbers for this particular equation. There are still some answers that we can discuss once we have progressed further in senior school. However, right now, the only thing that you need to be concerned with is that if the discriminant is less than 0, there are no solutions. So that's number one. Number two is if the value of the discriminant b squared minus 4ac is equal to 0, there is only one solution. Now, an example of that is if we have a quadratic equation which is x plus 3 squared equals 0, and we've seen a few of these. That means either x plus 3 equals 0 or x plus 3 equals 0, which gives you the same solution, or one solution to this particular problem. Now that leaves only one remaining outcome, and that is if the discriminant b squared minus 4ac is greater than 0, i.e. it's a positive number, there are in fact two solutions, and that's the type that we've mainly been dealing with. That means x is going to equal one number or another number. So that the discriminant, so if we're only looking to graph a solution, for example, we would use the discriminant to figure out, before we even start factorizing, whether it has no solutions, i.e. it can't be graphed, one solution, or two solutions. And in year 11, we'll talk a little bit about graphing quadratic equations and how this becomes extremely relevant. Okay, let's have a look at a few questions and see how we can solve them using the discriminant. Now, in each of these cases, all we're required to do is use the discriminant to find out how many solutions there are to a given problem. So for this one, x squared minus 9x minus 10 equals 0. We use the discriminant, b squared minus 4ac, to find out what the solution is. Now remember, these letters come from the basic form of a quadratic equation of ax squared plus bx plus c. So the coefficient of the x squared is a, the coefficient of the x is b, and the constant term, or the number, is c. So b squared minus 4ac in this example is going to be, well, minus 9 squared minus 4 times 1 times minus 10. Now I'm using brackets to help me distinguish between my positive numbers and my negative numbers. It's also important to put brackets around your negative numbers on your calculator because of the problem that we've discussed earlier. If you are squaring a negative number and you do not put brackets around it, your calculator will give you an incorrect answer. The square of minus 9 is actually positive 81. If you don't put brackets, your calculator will tell you it's minus 81, an incorrect answer. So this becomes 81 minus, well, 4 times 1 is 4, times minus 10 is negative 40, which gives us an answer of 121. So because the answer, or the value that we got at the end, is a positive number or greater than 0, we can say, therefore, we will get 2 solutions. And that's what we're looking for. We want to find out how many solutions we'll get if we were in fact to finish this question. Okay, number 2. Once again, the discriminant is b squared minus 4 times a times c, or 4ac. The value of b is minus 2 squared. Then we're taking away 4 times 1 times minus 14. Okay, this becomes 4 minus 4 times 1 times minus 14, which is 4 take away negative 56, or 60. Now again, because this answer is positive or greater than 0, there are 2 solutions to this problem. And last but not least, example number 3, or is there more? Yes, there's more. Okay, example number 3. The discriminant b squared minus 4ac equals minus 2 squared, take away 4 times 1 times 14. Now this equals 4 take away 56, which is minus 52. Notice how the only difference between example 3 and example number 2 was that there is a plus sign here, when in the previous example there was a minus sign. And the difference between that symbol means that the answer for our discriminant, instead of being positive, now turns into a negative, meaning because it's less than 0, there are no solutions to this problem. Okay, example number 4. Notice how this isn't quite written in quadratic in the general form. We need to move the 49 back over here so that it's in its proper format. This becomes x squared plus 14 plus 49 equals 0. Okay, now the discriminant, b squared minus 4ac, is 14 squared minus 4 times 1 times 49. We'll grab our calculators for this one. Okay, so 14 squared, take away 4 times 1 times 49 is, well, the answer is 0. Now because we get the answer of 0, that means, if we look back at our previous notes, that there is only one solution to this problem. So you've noticed that we've had all the different cases. We've had 0, minus, and positive numbers. So for this exercise, all we're really worried about is making sure that you understand that there are 3 cases: no solutions, 1 solution, and 2 solutions, and knowing how to use the discriminant to find each of those. If the number's positive, it has 2 solutions. If it equals 0, there's just 1. And if it's negative, then there's no solutions. Anyway, I hope you've enjoyed this video. Make sure that you ask for help if you need any help tomorrow with any questions that you've done. And I'll look forward to seeing you tomorrow in class. Have a good afternoon. Bye.